So then how do we say the fourth term is 19? Well, you probably guessed it. We'll use that capital U sub 4 to represent the fourth term. And the is an equals, and then 19. So this is actually an entire sentence in mathematics. Mathematics has grammar just like the English language does. And the verb in mathematics often is this is verb or equals. So we try and use complete sentences as often as possible in mathematics. So if we're trying to say something is something, we want to use that equal sign there. Likewise, we're not going to put the equal sign between two things that aren't actually the same. So in this case, we're saying the first term is 7, so we're going to use the equal sign. But we'll be careful later on to make sure we only use our equal signs when they are actually equal to each other. Okay, so we're going to go ahead and rewrite our example sequence. So our example sequence was 7, 11, 15, 19, 23, 27, ... so on and so forth. Okay, so this is our example sequence. So let's go ahead and list out the terms that we know in this sequence. We know that u sub 1 is equal to 7, and we know that u sub 2 equals 11, u sub 3 is equal to 15, u sub 4 is equal to 19, u sub 5 equals 23, u sub 6 equals 27. Now, can we write what a couple more of these are, even though we don't have them listed? Probably noticed a pattern. So based on the pattern, we've noticed what's going to come next. Well, from 7 to 11, we've added 4. From 11 to 15, we've also added 4. Notice for all of these, we've added 4 to the previous one to get to the next one. So I'm going to add 4 to that 27, so I get a 31. U sub 8 is going to be 35. U sub 9 is going to be 39. U sub 10 is going to be 43. Okay, so I've listed the first 10 terms of this sequence. Okay, that's wonderful. Now, what if somebody didn't have this list in front of them and you wanted to describe to them how or define to them this sequence without giving them the actual numbers? You want to tell them the pattern. For instance, you could say, let's start. So let me just put this down here. Okay, so describing sequences. When we describe sequences, there's two things that we need to be able to say so that somebody could come up with the same sequence. So the first thing we need to say is the starting point. The next thing we need to do is tell them where to go from there. So remember, we have to have the start and the rule. So it has to tell us, okay, for instance, add 4 each time is our rule. So in English, we would describe this by saying start with 7 and add 4 each time. Actually, let's change it. We'll say add 4 to the previous number to get to the next number. Okay, so let's go ahead and translate this into math language. The first part would be easy. Start with 7. Remember, we can just say u sub 1 equals 7. So that's going to work there. But this rule is going to be a little bit trickier. So what I'm going to do is first I'm going to reword this in English so that the direct translation into math makes a little bit more sense. So instead of saying add 4 to the previous number to get to the next number, I'm going to put this in a sentence using the is verb so that that can be my equals. So I'm going to say each term is the previous term plus 4. So I'm going to use this in place of this right here. Okay, so each term is the previous term plus 4. So let's go ahead and translate this. So I need my starting and I need my rule. So this is called sequence notation. So for a sequence notation, we're going to have u sub 1 equals 7 is how we translate this. Start with 7, or the first term is 7. Remember from the previous page when we wrote that. Okay, so the first term is 7. And then each term, so I'm going to go ahead and put a little key over here. If I use u sub 1 to be the first term, u sub 2 to be the second term, etc., I can actually use u sub n to just mean any general term. N can represent any subscript. So we're going to say u sub n is a general term, meaning it can be any term depending on what we want n to equal. If we wanted n to equal 1, it would be the first term. If we want n to be a 7, it would be the seventh term. But then if u sub n is a general term, then if we want to talk about the term before u sub n, we would want to take 1 away from n. So if n was a 7, the previous term would be u sub 6. And so we would want to do n minus 1. So u sub n minus 1 represents our previous term. So this is important to remember. You'll see this a lot, that u sub n is just any general term, anywhere you want to be along the sequence. U sub n minus 1 is the one before it. Make sure when you're writing u sub n minus 1 that the minus 1 stays in the subscript. It needs to stay small and down a little bit below where the normal script is. Okay, so in that case, since I've defined these, the general term is u sub n, and u sub n minus 1 is a previous term, I can say each term, I'm going to u sub n for that. So u sub n is each term, or any given term, is or equals the previous term plus 4. Well, we know for previous term we're going to use u sub n minus 1 and then plus 4. Okay, so each term equals the previous term plus 4. What we've just written is a definition of this sequence. So without seeing all of these numbers, if somebody knew this notation, they could look at this and say, oh, this is the sequence that starts with 7 and adds 4 each time. So they would know that this continues on indefinitely.